The next topic I want to talk about is how I've applied ChatGPT as a static code analysis tool. And we'll talk about why would I want to do this. And this is actually a really interesting and fun story. So I'm going to talk about how I've used ChatGPT, or augmented intelligence, to assess the correctness and the best practices of the programming assignment solutions by my students. And there's a paper we recently got accepted into a conference, the Foundations of Software Engineering Conference, that you might want to take a look at if you're curious. It's a lot of fun. It goes into a lot more detail. So this time we're going to be talking about grading the final submissions of assignments, which is not what I like to do. So of course I found ways to leverage AI to make life better. So let's talk about this, and we'll take a step back. So about a year and a half ago, this was fall of 2023, I was still at Vanderbilt. I was talking to some colleagues at a faculty retreat, and one of my colleagues, he's one of the best teaching faculty we have there at Vanderbilt, been teaching computer science for decades. His name's Jerry. And I said, Jerry, have you been playing around with ChatGPT? It's so cool. It's going to just blow your mind. He's like, no. I think it's not really very interesting. I'm like, well, you better be aware that your students may be using this stuff to do their programming assignments. You at least have to be cognizant of that fact. He said, Doug, my assignments are pretty darn hard. He teaches basically the data structures class. It's the second course that we take at Vanderbilt. And he said, my assignments are pretty darn hard. And so this is basically an assignment where they have to implement an abstract data type of a queue to simulate the plucking of a guitar string using the Car+Strong algorithm. Okay, and it's apparently an assignment that typically takes the students about 3 or 4 weeks to complete, and people really struggle with this assignment. So I said, well, let's see what ChatGPT can do. So I said, send me the PDF. So he sent me the PDF description, and it went off, and in that time it worked a little slower than it works now. So it chunked away for maybe 5 to 10 minutes. We just kind of sat there watching it, doing the solutions to the specifications that were in the programming assignment. And I could see his face was getting ashen. And he was like, oh my God, what's happening? And I said at the end when it finished and he realized that it was basically a perfect solution to this assignment that would take people weeks and weeks to do. I said, isn't that great? Isn't this exciting? It's a paradigm shift. It's going to revolutionize things. And he said, Doug, I think it's time for me to retire. So I thought to myself, well, Jerry, you're a great guy, but you're teaching like one of the intro courses. So it's not surprising that AI is going to be able to solve your problem. That was the night before the first day of class. So I thought, well, just for kicks, I'm teaching this upper division course that's much more complicated, parallel functional programming. I'll bet ChatGPT is not going to be able to solve my assignment. It's way too hard for any computer and AI to do. So I went home and I fed it my assignment, and like within 2 or 3 minutes, there was a perfect solution to my assignment. Well, now I had a problem. It was the day before the first day of class. When it was Jerry's assignment, I didn't care. When it was my assignment, I got a big issue ahead because I knew my students were not stupid and they would use ChatGPT because I was talking about how cool it was. They would use it to solve my programming assignment. So I thought, I've got to do something about this. Well, as it turns out, ChatGPT taketh away, but ChatGPT also giveth. Blessed be the name of ChatGPT. So I said, hey, ChatGPT, how can I modify my programming assignment specifications so they're harder to reverse engineer with generative AI? And of course, it being honest and earnest, it told me. It said, well, do a bunch of things. And it really boiled down to, don't give people as detailed specifications. Make them figure it out on their own. Now, again, this was a year and a half ago, so it probably can do a lot better than it did back then. But the point was, I said, okay, this is great. I'm going to change my assignment. I had to do this in a couple hours so that I left out a lot of the details of the solution. So that was good. However, I just opened up a new can of worms. The way I'd been grading my assignments to that point was I had some very detailed white box tests using a mocking framework called Mockito. That would, or I think it was actually, there was also one that was for Kotlin. It was Mock-K was another one. It's a variant of Mockito, which works for Kotlin. And so basically, the problem was that there were so many different ways people could solve the problem now because I'd underspecified the specification, the assignment, that there was no easy way to use a white box test to see if people were being correct or not. So that was causing a big problem. So I couldn't automatically check with white box testing and mocking, which is what I've been doing up to that point before. as you're probably familiar, if you ever use mock-based approaches for testing, they're really, really cool. The problem is they don't work with all the latest, greatest features that you would find in modern Java or very modern Java. But we had some pretty good stuff. But now I had a new problem. So the other way to solve this problem, the traditional way to solve this problem, at Vanderbilt, we had lots of undergrads who'd taken our courses who served as graders, and really they were TAs, we called them graders, but they would hold office hours and they would help people out with the assignments. Well, one way to solve this problem would be to have this army of graders descend on my student programming submissions, and then they would just grade them manually. But there's a problem with that approach, and the problem with that approach is called the inter-rater reliability problem, where if you have a group of people, you'll have people who are easy graders and people who are hard graders. So now you've got this issue where any given student, depending on who grades their assignment, may get different results, which isn't fair. It's very much like sporting events where you have judges from different countries, and the Soviet bloc judge always gives the Soviet gymnast or ice skater the high scores, and the American bloc judge will always give them the low scores, and vice versa. Right? So this is a well-known problem. So I didn't want to go that route. So what I decided to do instead was to use AI. And this was going to solve all kinds of things. First of all, having very tightly scripted specifications cuts down on people's ability to be creative. So there's virtue to relaxing the specs, even above and beyond having to have a harder time grading. But it also forced me to think very carefully about how to use AI to make life easy again. So let's talk about this. So I have used augmented intelligence to improve the way I assess assignments for my CS courses. And this is a nice AI-generated Android, because we were using Android, which I think this is a fun little representation. So this is how I teach my programming courses. It's a very unconventional way of doing things, but it's great. Students love it. So what happens is the assignment is due at some point, and students have to submit the first version. They submit the version. I then review everybody's solution and look for frequently made mistakes. And I leave comments in the code saying, you need to do this, you need to do that. And I compile all those frequently made mistakes into a big list. I'll show you that in a second. Then I give the frequently made mistakes list out to the students, and then they are given an opportunity to revise their programs. And when they revise their programs, then they resubmit them with the revisions, and then my TAs and graders give the final assessment. So that's the way it works. So what I did is I came up with a way to get ChatGPT to automate key steps here in order to make this more scalable and to solve the inter-rater reliability issue. So this is the way this works. Typically, I would read all the code, and I would keep a list in Emacs, because I'm an Emacs user. I started using Emacs here at William & Mary in 1984, I think it was. So I've been using it for a very long time. And I would write all the mistakes people made in this file, and then I would make a video called the Frequently Made Mistakes video, where I would walk through the anonymized mistakes and tell people what they were doing that needed to be improved. I don't typically say the solution, but I say this is the problem, this is what you need to think about to solve it. So we end up with this video and a file. Now, the problem in the past was every semester I would teach this course, people would make pretty much the same mistakes, but I would have to go back from scratch and do this whole process manually, which is fun, but it's also a lot of work to try to do manual reviewing of things. And it didn't scale up very well. So if you have a class with like 150 people, this was impossible. I usually had a class of about 35, so it was doable. So what I did is I taught ChatGPT to take my frequently made mistakes file and then generate from it a structured rubric in JSON that would say what the name of the problem was, what the description of the problem was, how it could be done correctly, how it could be done incorrectly. And I would do that it would automatically generate this JSON rubric from my frequently made mistakes list. So that's pretty cool. So that's thing number one that I did. But that's only the beginning of this. And then what I would do with my students who helped me, my TAs, we would take the rubric, and then he wrote a Python script and basically said, imagine you are a grader for a parallel functional programming course taught in Android with Java, and I'll give you a rubric, and then for each item in the rubric, you will first basically go and look to see whether the student's code either does or does not do the things that were in the rubric, and you'll output a grade, and the grade was basically just a binary value. It either matched and passed or it didn't match. It was pretty simple. And for each of the things that I'd come up with as frequently made mistakes, it would review each student's code. And so this Python script would then call out to ChatGPT using their API in order to feed each student's solution together with a rubric and then get back for each student the results. And that would then go into a directory. So it was all very, very heavily automated. And of course, even though there was a lot of AI going on here, the human TAs and graders orchestrated the whole thing. So they were keeping track of this stuff. And it saved an enormous, enormous amount of time, as you can imagine, because they didn't have to go through every student's code looking to see if they'd addressed my comments. Wow, that takes a long time. The other nice thing about this was I no longer had to rely on my TAs and graders reading my mind in order to figure out what I wanted the rubric to do. That was basically outsourced to the rubric, which came from the list of frequently made mistakes. Therefore, we had addressed the inter-rater reliability problem, because I only needed one TA to do this whole thing. I didn't need an army of TAs or graders to do this analysis and thereby having inconsistencies. So we ended up with results that were much more consistent, way more fair. Typically, if you're trying to grade programs and you have lots of them, the first 10 or so you do a really good job on, and then from 11 to 110, you zone out. It's just human nature. It's very hard to keep focused on these kinds of things. Your brain turns to mush after a while. So we also used a private version of ChatGPT, so this was not giving people's code out to the world to be trained on, which is important. And the best part of this is because of the fact we used augmented intelligence, issues with false positives were quickly discovered. So false positive would be something where someone would mark a student's solution down either because they thought there should be something that was there that wasn't, or there was something there that shouldn't have been. And sometimes people make mistakes. Graders make mistakes all the time. So what we did here to avoid this problem were two things. The first thing we did was the graders would take a look at the output from ChatGPT, and everywhere it flagged a problem, they would go spot check. Is that really a problem? But that took way less time because there were usually very few problems because students had a chance to fix their code. The second way this worked was when you give the students their grades back, they will very quickly discover where you've made mistakes. So there's a sanity check feature here where they will actually look and say, hey, wait a second, you said this code is wrong, but it's not wrong. So there were really no way that people, unless you were incredibly negligent as a student and never cared what grade you got and to see if you actually deserved the grade, we would always have any problems with false positives addressed. So there were very rarely any of those problems, but when they did occur, it was easy to catch them. Now, last piece of insight about this. This is really, really cool. So AI and augmented intelligence works best when you work with it iteratively. And I'll be honest, it took me a while to learn to write the prompts to catch mistakes in the student's code. Because remember, people were doing things in very creative ways. And so there were lots of different ways they could get things wrong. And I had to come up with prompts that described the problems, and it had to cover a wide range of problems, wide range of variations of things. And so the first couple times I would do it, sometimes it wouldn't catch things that I knew were mistakes, but it hadn't figured out how to catch them. So what I would do when that occurred is I would engage in Socratic dialogue with ChatGPT. I would say, your answer to question 6 was incorrect. There is a Java for each loop in that method, but not a traditional index-based Java for loop. Please help me rephrase this question so you answer it correctly the first time. And so it would say, oh, okay, fine. If you rephrase the question as blah, 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 then I'll be able to see better about how to find those mistakes. This is really cool. It's a great example of Socratic dialogue, right? You are engaging in a discussion with the tool, getting it to tell you how to do a better job of making it work effectively. If you've ever worked with static analysis tools, you know it's impossible to do this with other static analysis tools. If you have a static analysis tool that you have to write convoluted logic, prepositions, and so on, and you get them wrong, good luck asking the tool to tell you how to do a better job. Or if you go to your compiler and say, hey, compiler, why are you giving me a syntax error? The compiler's like, that is a syntax error. I do not understand the question. So the great thing about ChatGPT, or really LA, large language model, is you can negotiate, you can learn, you can teach it. It can tell you how to do a better job. That is really, really valuable from an education point of view. Okay, so that's the end of the discussion about augmented intelligence for automating grading.